So today on Notes 9, we've been talking about function notation for the last couple of notes, and today we're actually going to see if a given set of data represents a function or not a function in the situation. So how to tell from a table. For every value of x, there can only be one unique value of y. But it's okay to have the same values of y if there are different x's. So just remember, all x values have to be different. So on number 1, is this a function? Yes or no? Again, only look at your x column. It doesn't matter. Your y's could all be the same. It doesn't matter. The x's have to be different. So yes, this is a function. Here, our 2's repeat. So this is not a function. Number 3, these are all different. So yes, it's a function. And here, these are all different. So yes, it's a function. And then let's look. We've got a 2, we've got a 3, and we've got a 3. So this is not a function. Now, let's take a look at number 6. Remember, this is the order pair 1, 0. And this is the order pair 2, 5. So 1 and 2 in your x values are different. So yes, this would be a function. Let's take a look at the mapping area. There cannot be 2 arrows going from the same input to 2 different outputs. So just look at these right here. This is a no, and this is a yes. But there can be more than one arrow going to the same output value. So is it a function, yes or no? So this basically is 2, 3 as an order pair. This is 4, 8, and this is 5, 1. So yes, this would be a function. On here, 8, 10, 7, 12, 6, 12. So you see how these two right here go to the same y value? That looks very similar to the yes up here. Okay, so this is okay. If you need to, you can make a table of values if it helps you. So this would be 8, 10, 7, 12, and 6, 12. And again, only look at the x values. So yes, this is a function. Number 9, negative 1, 4, negative 1, 5. Oh, look what happens. Your negative ones repeat. So this can't happen. So this would look like this right up there. Number 10, 5, 2, 6, 1, 6, 3. The 6 repeats. It can't do that because 6 is your x value. Okay? So just remember in a mapping, this first oval is your x, and then that's your y. So this would be a no in that situation there. So then let's go on and look at how to tell from a graph. And this is called a vertical line test. So it's a function if you draw a vertical line on any part of the graph and it only crosses the graph one time. If it crosses more than once, it is not a function. So your pass is only cross right here, one cross. Your fail is it crosses greater than 1. So right here, I mean, you can even see on number 11, the y-axis, that graph hits it there and there. So it fails. So this is not a function. Number 2, again, you can look at the y-axis and it only hits that y-axis one time. So this is a pass. So yes, it is a function. On this one, you can draw a line anywhere. Like it hits the y-axis one time. I could draw another line over here. It hits it one time. So it passes. So therefore, yes, it is a function. Number 14, anywhere that I draw, I could draw a line there, I could draw a line there, I could draw a line there. It only hits that line one time. So this is a pass. So yes, it is a function. Now on this one, if I draw a vertical line right over that line, it hits it infinitely many times. So therefore, it fails. So this would not be a function. On number 16, if I draw a line through that point, it only hits it one time. But look over here at these 2 points. It hits it there and it hits it there. So therefore, this would fail and it would not be a function. All right, let's go ahead and look over on the second page. And this is the one I want you to try. So if you want to pause this and then go through and try it yourself, that would be great. So letter A would be a yes. B is a yes. C, nope. If you draw a vertical line, it's going to hit it multiple places. So that's a no. D, well, you can see on the y-axis that it only hits it one time. So this would be a yes. E, okay, we can just draw it once there, even once over here. That's not a very good vertical line. Here's your vertical line. It only hits at one place. So yes, this is a function. Let's look at this mapping. This would be an order pair 1, 3, 2, 3, 5, 3. So the y's repeat. That's okay. Remember, the x's can't repeat. So the x's are all different, so that would be a function. Let's take a look at letter G. We have -1, 5 is an order pair. Then we have 0, 3, 1, 5, 2, 11, and 3, 21. So none of the x values repeat. So yes, this is a function. Let's look at letter H. All we're looking for, the input, which is your x value, making sure that they're all different. So blue, red, and white. So yes, this is a function. And letter I, now again, this f of 3, this in parentheses is your x. So we have a 3, 5, 5, and 6. So these are repeating. So this would be a no. And over here, the name would be the x and the age would be the y. So again, we're only looking here. So you can't have the same Blaine to be both 8 years old and 16 years old. That's just not feasible. Now there can be different Blaines, but I'm talking about if this is the same Blaine. So this one would be no. And then let's look here on more practice with evaluating function notation. So on 17, it says given f of x is equal to 5x squared plus 2x minus 8, find the range if the domain is 8. So you can put this in your calculator, either just in the home screen. You can go ahead and just put 8 in place of each x, or you can do what this represents right here in your calculator. You can do that. So if you want to pause and do that, you can. I'm just going to show you what it looks like by hand. So we have 5 times 8 squared plus 2 times 8 minus 8. All right, so 8 squared is 64. Then 64 times 5, let me calculate that, is 320 plus 16 minus 8. So we have 320 plus 16 and then minus 8. So that gives us 328. All right, let's look at number 18. It says given g of x is equal to 2x squared, find the range if the domain is all three of those numbers. Okay, so again, you can put this all in your calculator. There's a little bit different way that you can put it in. So I would encourage you to practice the different functions on the calculator. But just to let you know by hand what it looks like, we would take 2 and -5 squared. So -5 squared, that's -5 times -5, which is 25. So 25 times 2 gives us 50. Then if we have put in a +5, it does not matter whether you have a +5 or a -5. So here, it's as long as you square it, because 5 squared, that's 5 times 5 is 25 times 2 is still 50. And then, of course, with 0, I just waited last for this because we square 0, get 0. 0 times 2 is just 0. So remember, when it wants us to list these, we put them in order from least to greatest. So it'd be a 0, comma, and just write down 50 one time. And then let's go to 19. 19 says find the domain when the range is 42. So on this one, we're going to put 42 in place of f of x, because the entire f of x means y equals. All right, so I'm going to write it like this. I'm going to go negative 5x minus 8 equals 42, and then it's just a two-step equation. So I have a variable term, I have a constant, and I have a constant here. So I'm going to get the constants on the other side. So I'm going to add 8 to both sides. So I have negative 5x equals 42 plus 8 is 50. And then I divide both sides by negative 5. So x is equal to negative 10. So that would be my domain is negative 10. So negative 5 times negative 10 is 50. 50 minus 8 gives you 42. All right, and then let's look at number 20. It says find f of x equals negative 5x minus 8. Find the domain if the range is 42. All right, so I'm looking here, and it's the same problem for some reason. So we can just, I guess, eliminate that. But it does give us another way. So maybe that's why I probably repeated that, just so you could, one, work it by hand, and then two, you could use the calculator functions here, okay, in this box. So I guess that's why. And I wanted you to see that you would get the same answer no matter how you worked it. So a lot of this is practicing using your calculator functions, which will come in quite handy when you're working later on with quadratic equations as well. Quadratic is where the x is squared instead of just a single x like that.